If the diagonals of a parallelogram are equal, then show that it's a rectangle. So I'll have a diagram which is common for all. Suppose that you guys have to describe the diagram, talk about what is that we have been given and what is that we need to prove. So all this you guys have to do it. Okay, and yes, please take care of this, that the diagonals are equal. You need to see to that you take that into account. So we have this are the diagonals and they are equal. So now how do we go about doing this, that you guys have to figure out. Till to prove, write the initial things. Okay, let's begin with, let's consider a parallelogram ABCD where AC is equal to BD. The diagonals are equal. Now let AC is equal to BD be equal to 2x. Okay, we need to do this. I'll show you why. Then let O be the point of intersection C intersection of the diagonals. Okay, so if this is a point of intersection, then what can we tell? Then we can tell that OA will be equal to OC, which will be equal to x, which will be equal to AB by 2, which will be equal to x. And on the same line, OB is equal to OD, which is equal to BD by 2, which in turn will be equal to x. Reason: diagonals bisect each other. So this is a property of a parallelogram, is it not? Okay, so this is something that we have to write. So this, all the sides are equal. Again, this is exclusively given, so we need to make such conclusions. Okay, so we need to prove that ABCD is a rectangle. Now, what makes a parallelogram a rectangle? That's the question you need to ask. So first you need to answer that. What makes a parallelogram a rectangle? All the angles are equal to 90 degree in a rectangle. Okay, so indirectly if we prove this, we'll be able to prove that. So take some angle, so these two angles should add up to 90 degree. So this angle should be equal to 90 degree. If you prove one angle, that's enough. So that should be your agenda. Okay, so how do we go about that? You need to think. So I've given you enough clue. So you guys have to think over how to do this. Okay, so let's start. So there are quite a few ways of doing this. So I'll use variables. In triangle OAB, okay, so I'm considering triangle OAB. OAB, OA is equal to OB, right? Because they are equal to x. Thus, angle OAB will be equal to angle OBA, and let's call it as some variable E. No, so these two are E. Why? Because angles opposite to equal sides are themselves equal. Okay, how does this help? See, the point is I'm trying to use collinearity. Okay, not collinearity, sorry, co-interior angles. See, end of it we need 90 degree, remember. So how will we get 90? By adding all the angles we get 360, or we can use one more thing. These two lines are parallel, so the co-interior angles will add up to 180 degree. So I'm trying to get an expression for co-interior angles so that we can prove that they are equal to 90 degree. So I'll show you that. Till then it's kind of confusing. So we prove that these two angles are E. Now next thing, angle ODC is equal to angle OBA will be equal to E. So this too is E. Why? Reason being AB is parallel to DC. So alternative interior angles are equal. Okay. So with all of this and that, we have in triangle OAD, we have OA is equal to OD, right, which is all of this is equal to X. Thus angle OAD is equal to angle ODA, which is equal to say F. So if this is F, this too is F, right? So reason we don't need not write, we already written a similar thing. So then we have, right, in parallelogram ABCD, angle BAD is equal to angle ADC, which is equal to 180 degree. Reason, AB is parallel to DC, right? And these two angles are co-interior angles. And with co-interior angles. Okay, so these words are enough. So from the diagram we have E plus F plus E plus F is equal to 180 degree. This is from the figure, right? We are substituting all of these values. So 2E plus 2F is equal to 180. Divide with 2 throughout. So E plus F is equal to 90. Since one of the angles is equal to 90 degree, right? That's what we wanted. Thus ABCD is a rectangle. Okay, that's it. We are done. This is a bit tough question. Compared to this, it's actually lengthy, right? And yeah, you have to know quite a few properties. So yes, I will grade this as a tough question.